Okay, awesome. Amazing to see this pretty large crew out here. My name is Claire Longo. I work for Comet. We are a tool for experiment management, LM evaluations, and tracing. We plug into machine learning and AI projects. What I'm going to talk about a little bit here is my own personal project. The way I like to learn technologies is I have to get hands-on with it. And what better way to do that than to think of your own personal project, something that interests you, and just start building. So what I did here is I had to learn my company's new tool. We released this amazing open source tool called OPIC. I had to learn it, and I really wanted to understand what my customers are going through, what y'all are going through as you build out RAG systems, so I went ahead and built my own. It's an AI clone of myself. I was trying to automate maybe some stuff I don't want to do, like send emails, so I'll show you how that went. Okay, so what I'm going to talk through today in general is I'm going to give you kind of the step-by-step for building an LLM app with open source tools. There's a couple open source tools that I used. OPIC is one of them. There's a few other ones that I used to piece this together. And then I'm also going to talk about testing and monitoring an LLM app. Once you build that LLM and it's moving into production or it's live in a notebook and you've got people interacting with it, you've got to really think about how you're actually monitoring that. How do you know what's going in, what's going out of that system? How do you debug any issues? So there were some kind of LLM ops best practices that I learned through putting this project together, and I'm going to share that with you. The way I'm going to actually present all this is I'll just show you my personal project, what I built, why I built it, what it does. I'll give you a live demo and show you the open source OPIC tool. And then we're going to do a bit of deep dive into the technical components. This is a RAG system, so there's a prompt, there's a model, there's an orchestration layer, and there's also, probably most importantly, the testing and monitoring component. Before I dive in, I want to get a show of hands. Who here knows what a RAG system is? Oh yeah, very technical crew. Who here has built one? Amazing. I'm going to go pretty fast through the kind of basics of the RAG, because I think you all know what this is. First thing that you need when you're building a RAG is a large language model. So what is a large language model? It is an NLP model. It is trained on billions of words or more. It is using encoder and decoder architecture through the transformer. I'm not going to go into technical detail on that, but it's really this kind of powerful infrastructure of this deep learning model that encodes the patterns in human language and allows these models to be really good at language-based tasks. So we've got access to these things, very powerful. The one I used is through OpenAI, but there's a lot of open source kind of APIs so that you can build your own stuff on top of this. Google's Bard, Meta's Llama. This is everything the Silicon Valley is talking about right now. So what can you build with LLMs? So I'm in a pretty cool position at Comet where I get to work with a lot of our customers. And the thing I love about this role is I get to see what they're building. And over, I'm seeing these kinds of projects. Large enterprises, one practitioner, small companies, they're all kind of building the same stuff on top of LLMs. And here's what they're building. They're building summarization tools, translation, question answering, that kind of customer support bot, even creative writing like poetry. But these are all language tasks. So these LLMs are really, really great at language tasks. They're not going to be your computer vision model. I don't think they're so great at mathematics, but there's a debate out on that. But it's really those kind of language-based tasks is what people are building here. To build something like this, it's not just a single call to an open source model like OpenAI. It's typically quite a few puzzle pieces. So there's actually going to be multiple steps here. There might be some kind of routing logic. There might be some like prompt engineering that you need to do to really make sure that your app is focused on a very specific task. So what you have to do is you have to pick some different puzzle pieces. You might need a vector database, things like that. You got to figure out what these puzzle pieces are and put it together to build your kind of custom specific application here. And that's where these kind of open source tools come in that I'm going to talk about. I use LangChain. There's a lot of other options here. And then definitely Comet OPIC for the testing and monitoring and logging of the traces, the inputs and outputs. And then OpenAI was the base model that I used. Okay, so what did I build? Meet ClaireBot. It is a conversational RAG bot that is augmented by my own social media data. The reason I did this is I was using ChatGPT to draft my emails, and it did not sound like me. It sounded like ChatGPT. And I did not want to send those emails out. So what I wanted to really test this technology and see if it could do it, I wanted to see if it could sound like me. Could it think like me? Could it reason like me? Could it write an email the way I would write an email with the same misspellings and maybe grammatical errors and that kind of thing? So I used a RAG for this. My diagram is not nearly as good as Corey from Pinecone, but I think y'all can follow this and you've seen the RAGs before. Essentially what it is a query comes in. I'm going to retrieve some context data. I just chunked up data from different sources like Word docs and some downloads of like my emails and stuff. And then relevant data is going to be retrieved. That's injected into the prompt. That goes into the LM, which is OpenAI, and then you get a response. So what does Clairbot do? I wanted to give her a very specific task so that I could evaluate it, because my real goal with this project was to really study LLM evals and figure out how we can evaluate these systems, make sure that they're executing the tasks that they're instructed to, and build some kind of like custom eval metrics to keep track of these things. So I've seen my customers giving RAG systems very specific tasks, like maybe they're doing like trip planning, customer service, specific retrieval around like software documentation. I decided to do something fun. I made it into a personal stylist. So that's something I really love, is kind of like a side interest and a hobby. I love fashion, I always have. And so I was thinking, wouldn't it be cool if you could upload an image of your outfit and work with the LM to really kind of get recommendations of how to improve it? So it operates as your personal stylist. You send it a picture of your outfit. You tell it what you want it to do. So in this example, I'm saying, I'm going to a Christmas party. I need to make this more of like a Christmassy outfit. And what it should do, if the app is working the way that it's programmed to, is it is going to give you actionable style advice. So it's going to be helpful, it's going to be kind, and the advice that it gives you is actionable. So the real reason I did this is I wanted to measure actionable. What does that even mean? How do we put a metric around that? Because that's something that I see a lot of people who are building RAG bots kind of struggle with. So let's take a deeper look at this system and where it needs to be evaluated. So you've got the image coming in, and the image needs to be analyzed. Now, the LLMs are not really processing the image data. They need to process text data. So there's a lot of different ways to kind of get this to work, but the way that I approached it is I used an open source image to text model that would translate the image into a text summary, and I'm using the text summary in the rest of the system here. So the first step is to transform that image to a text summary that describes the image in an eloquent way that's going to be meaningful in the model. And I downloaded an open source model from Hugging Face, so that is our first open source tool here. So then an image summary is returned. That's going to go into a prompt. Another thing that's going on that also gets injected into the prompt is the conversation with the chatbot. So you might be chatting with Clairbot, and she's learning about your personal style, where you're going, what you need to do with the outfit, things like that. And so all that kind of personalized information is also being collected, and that's going to be injected into the prompt, so you get a very personalized, actionable output out here. Last thing is the advice, and you'll see I put these little stars across this diagram. This is where this system needs to be evaluated. So overall, I don't want to just test like, hey, is this accurate? I need to test at each step if it's doing exactly what it was instructed to do. So the first thing that I want to keep an eye on is the image. Is it an outfit? Is someone sending pictures of their food or whatever? Because the app is not going to be able to know what to do with that. So we've got to keep an eye on that kind of output. We need a metric to monitor there. Next is a conversation topic. Is it meaningful? Is it relevant? That's something we need to measure. And then last, you want actionable advice and moderation. So moderation, this is really common kind of metric in LLM systems. You want to make sure they're not going off the rails, fairness, bias, those kinds of things, sensitive topics. So there's kind of a general metric that I'll show you guys in the live demo that we're using for the moderation. Okay, so I'm going to jump into some real code. I've done a few demos, so I know to run my code ahead of time just in case something goes wrong. But I'll walk you through what I built here. So the first thing to look at is the packages that I'm using. Completely open source. Zoom in? Yeah, I got you. 1 second. A little bit better? Okay, good. Yeah, thanks for calling that out. So first thing to notice is the packages that I'm using. Completely open source. I'm using LangChain for orchestration. I've got OPIC for the tracing and evaluations. And then I'm using OpenAI through LangChain here. Oh, we've got the blip model as well. which is the image processing. So first thing I gotta do is make a prompt. You all have seen this before. I'm just telling this thing what its task is, what the expected output is. The interesting thing about this, though, is that as I'm building this, I need to iterate on the prompt. I need to try different sets of instructions and measure how better the system is. And that's where OPIC really comes in, is giving you a way to experiment, to track what you've done so you're not kind of getting lost. To also be able to, in a more scientific way, keep an eye on what you've tried, what worked, what didn't, so that you can reproduce it. And then also a framework for even generating those metrics in the first place. Let's see, what's most interesting here? Okay, so this is the actual code of kind of the meat of this application here. The thing I want to point out is the OPIC integrations. So OPIC is an open source Python library, and it's really, really easy to integrate. As a developer, I don't like to get stuck integrating new tools. I want it to just be a few lines of code. I want it to be really intuitive. So what I love about this is I'm just importing OPIC, I'm instantiating it, and then I'm creating something called a tracer. And this is what's gonna scoop up the inputs and outputs of every step that I showed in that diagram, or we're gonna see that in the UI so that we can actually visualize those inputs and outputs and debug them. And the way that we are doing that is you'll see this little kind of, where's a good example? Go into moderation. So this is our moderation eval. So I talked about how we need to keep an eye on this thing so it doesn't go off the rails, measure it for like fairness and bias. So the way I'm doing that is with a moderation eval, and that's through OPIC. And this is the code where I'm defining that. I'm gonna jump in and show you the inputs and outputs in OPIC, and then we'll jump into the metrics. So now I'm in my OPIC UI. This, when you run your application, this data is going to be automatically scooped up because of that Python integration that I showed you, and it'll just show up automatically here. What you're looking at is the inputs and outputs of traces. So I can click into one of these, and you see those same steps from the diagram I was showing earlier. So one trace is going to contain multiple spans. There's that call to the blip model to process the image. There's that back and forth conversation where I'm collecting personal preferences. And then finally, there's that call to OpenAI. And what's cool is I can see the inputs and outputs on all of these here. So if the bot starts saying stuff that's weird, or if it starts breaking, I'm going to be able to pinpoint exactly what those inputs and outputs are. And the way that's helpful to me in the development phase is it indicates maybe how I should change my prompt. And it did. I started seeing like, oh, it's not really out analyzing the image, like it's looking at the background. I could put that in the prompt. I could force it to look at the main subject of the image described in the summary. So I was doing those kinds of like iterations as I experimented with the right prompt here. Now, the other thing to notice is feedback scores. So this is one of the most powerful things in OPIC. I like to think of OPIC as a framework both for logging the traces like I showed you, but also for generating these evaluation metrics. Show of hands here, who has worked with LLM as a judge? Is that a familiar concept? All right, this one was absolutely wild to me. So when you think about measuring the performance of like a machine learning model, we've got great metrics available to us. We got our accuracy, ROC score, AUC, F1, whatever it is. It's very mathematical, it's very tangible. I liked that. This is a little different. This is more uncertainty is introduced. So when you think about evaluating an LLM system like this, how do you measure things like moderation? You probably want to label it, such as you would like in a classification framework, as like bias, not bias, toxic, not toxic. So kind of putting it in that classification framework. Well, the question is, how do you do that? And the way you do that is, ooh, I'm not connected to the internet, but I have an example up here. So this is my topic eval. The way you do that is with a prompt. So you are essentially, the LLM as a judge, is you are asking another LLM to evaluate your LLM's output. So you're really just kind of creating this really interesting situation where you've used the LLM for a specific purpose, and you need to now evaluate it for something else. So now you're calling another LLM with a specific purpose of evaluating. So it's really just a prompt, and in this prompt, I'm almost casting it to a classification. So in this prompt, I'm telling it, you're the judge of staying on topic, your job is to make sure this and that, blah, blah, blah. And then at the bottom, I'm instructing it to return JSON format with the label, which is gonna be a 0 or 1, topic or off topic, and then reasoning. And the reasoning here is very powerful because now you've got some insights you can look at if it is labeled as like off topic or toxic or something like that. Oh, I lost my name tag. Then you're able to really get some insight into why, and that helps you improve the system overall. The thing I wanted to show here, and let's see if it loads. Yeah, we're not lucky. So we have a bunch of out-of-the-box, pre-built LM as a judge metrics for things that LMs do all the time. The fairness and bias one, the hallucination. People are using LMs to write SQL, so we've got a LM eval for is SQL or not, things like that. Super useful. But what I've learned is that as customers are using this, they all have like really unique use cases and they need to customize it. So we're also offering that framework that I was showing where I wrote my own prompt. And you can really just kind of leverage this ability of casting this into a metric to monitor your system for anything that you're really concerned about. So that's what this is right here. You see I have the moderation eval. Its score is 0. That's good. That means it's doing what it's supposed to do. And when I highlight it, I know it's kind of small, but what you're seeing here is that reasoning. So in the LM as a judge eval, I asked it to tell me why did you score it this way, and that's actually going to be displayed in Comet as well, or OPIC. Cool, so that was live demo. Let me jump back here to generally this. So here's kind of the LLM ops lessons that I learned from doing this. There's really 3 phases that I went through in this project, and we've got to think about challenges in all 3 of these phases. The first one is development. That's where I was iterating on stuff. I was trying different prompts, maybe trying out different models, tweaking the parameters on that. In that phase, I need to be very scientific-minded about what I'm doing so I can reproduce anything that I really liked, and so that I'm confident in my results. If I just run a few things with a different prompt, take a glance at the output with a few samples of data that I like, and like, yeah, it looks great, that's kind of a vibe check, and it probably won't scale in production. I really need more of a scientific way to do this, and so by leveraging Comet, you're able to kind of run these eval metrics at scale across different data sets and do those side-by-side comparisons and version your prompts and everything while you're doing that. The next one is unit testing. So if I was to really like deploy this thing into production, this would kind of be the next thing I need to think about. As you're iterating over this, you need to kind of verify your LM application performs as it's expected across these kind of moving parts. So we do have like some CI/CD integrations that are going to help with some more kind of standardized testing here outside of the notebook. Last is production. The kinds of metrics that I was looking at as I was iterating and developing in the kind of early research phase, now I probably want to monitor those as people are actually using the app and the data is coming in at a larger volume. I need to track the trends of things like moderation, off-topic evals, hallucinations, and I might even want to get alerted to things once they start to go wrong. Generally, this is what Comet OPIC helps with. If you are fine-tuning, I didn't talk about that because I didn't have to do it for this project and it's very expensive, but if you are fine-tuning, we're also very helpful there, and that's still kind of like framework of experiment management. If you're fine-tuning a model, it's very similar to just training a model, and you need to track what you did there. We help with the prompt engineering, versioning things, logging the inputs and outputs to see which prompt templates are better. Then there's data versioning. So as I mentioned, you want to run these kind of scientific experiments. You need like a golden data set, a baseline data set to really run things on as you're iterating. Evaluations, this is the hard part, kind of the creative part. But these are those LLM as a judge evaluations that I talked about. We also have some heuristic metrics built in, and that ability to totally customize your evaluation metrics. And then last of all is monitoring. Once you've got all these pieces in play and you've got a system in production, you gotta make sure it's not going off the rails, and this is a great framework to do that with. And OPIC is open source. We love stars, so you can scan this, and if you want to check out our repo, it's all there. But that is all I had. If you want to get started with OPIC, it's really just a few lines of Python code. If you're in a Jupyter notebook, if you're familiar with Python, you're going to have no trouble getting going with this. But yeah, thank you. Any questions?
Hi. You showed us a schematic in 2 places of your architecture, right? Is there a way to, in a high fidelity sense, suppose you define that implicitly in your code in OPIC or even LangChain, get a view of that as, suppose you switch out an LLM in one place. The schematic gets auto-regenerated, and then you can see like what exactly is going on. Like, my question is that a post facto diagram that you generated, or is that a first class object within OPEC?
Yeah, which diagram were you talking about there?
Back.
Are you talking about
Yeah,
this?
these types, yeah.
Yeah. So I generated this after building the bot, and I did kind of iterate on what this architecture should even be. Because there's a lot of design decisions, like how are you going to integrate the image analysis? I think there's like a multimodal modeling approach that you could have taken here. I took an image summary approach. So this is kind of capturing what I did. The important thing here, though, the thing to point out is once I had this, it's these stars that I think were really key. It's like figuring out like, okay, I know what the system does. Where can it go wrong? And placing those stars on like, okay, these are the breaking points, and then coming up with an evaluation metric for each one. Yeah, but OPEC's not going to help you with this. They are going to help you with the evaluation at each point. Yeah.
I just add a comment. It would be really useful to look at this schematic in your, so you had a place where you showed the logging, right? It would be useful to see that in the context of this schematic. So
I see.
That's what I'm doing.
Yeah, it's good product feedback. I like it. Thank you.
Oh, sorry.
So there's a couple, besides like OPIC, there's a couple other like open source tracing tools, but it's really hard to tell the differences based on their homepage.
Yeah.
Could you give us like a quick like summary of some of the differences between all of them? So
Yeah.
I end up using like whatever's in like the starter like examples.
Okay, yeah, good question. That is also how I build. I like to copy paste a lot of code, and that's how I ended with Hugging Face. Like they have amazing online tutorials, and that's what OPIC is trying to do as well. So it's kind of led to my design choices, like what can I get access to in terms of the Hugging Face choice. In terms of the tooling, there's a lot of tools. I would say try them out, evaluate them, come into it with like a real tangible project and like questions that you need answered, and just choose what's best for you. I've worked for more than one of these companies. They're all fantastic, but I think you kind of gotta see what's best for your project.
Hi, I wonder if there is any chance that we can visualize if our model worked well or not. You know, somehow seeing if, for example, each part working well, each one it's converged or not, something like that.
Yeah, it's a good question. That's something I would love to spend a lot of time researching. I think it's an open question. Let me know if you solve it. There's a couple things you can do, like with the evaluation metric in production, you can plot it over time. So if you see it kind of going off the rails, that's helpful. In the development phase, I was using experiments and then side-by-side comparisons. So it wasn't really like a convergence, because there's really no model training going on here. It was more like I used prompt 1, I used prompt 2, I ran it on the same data set with examples that were curated to represent everything I want this thing to be good at, so like a good like representative of production data set. And I did a side-by-side comparison with the metrics, so I could see like hallucination is high with this prompt, low with that, things like that.
So you surveyed somehow, yeah?
Yeah, because it's not converging the way if you were like machine learning, like model training or fine tuning. Yeah. Good question.
Are there any problems that you were hoping OPIC would solve for you that it didn't end up solving? And if so, how are you addressing them?
With the good questions back there. Any problems that we should be solving with OPIC that we haven't? Is that the question?
That you wished OPIC would solve for you, like you picked up the tool expecting it would help you with a certain problem and then it didn't cover that problem?
Yeah, really good question. OPIC is still new, it's developing a lot. So I would say use it hands-on and give us product feedback, because as this field grows, it's gonna grow. And it's open source, you can like get in there and contribute. One thing that I think we haven't solved it as an industry, and OPIC definitely is not addressing yet, is how do you mathematically evaluate these things? I showed you LLM as a judge. It is an LLM judging an LLM. That's super wild. It's what we're using, and I love it, and it's customizable, but it's wild. I would love a mathematical way to like capture the confidence intervals around this and this probabilistic output of these models. That's something, like I know perplexity is a really good metric, and we have a good blog post on that one. But that's something that like I want to spend a little more time on and figure out how to facilitate. I don't know the answer, but it's interesting.
It is interesting.
Yeah, good question.
All right, we have time for one more. You choose.
Thank you for choosing me. So my question is, why do you think LLM and large language models are so bad at doing math, even the simple ones, but they are very good at, they're very amazing at doing other things. even like coding, if I put it in the code, do an integral for me. It's able to write that code for me, but doing a very simple integral, it's not able to do that. What's the reason for it? And the second question is, how can they be improved?
That is my
in doing
favorite
that?
question, because that's something that I care about a lot and have thought about a lot. So code is language. So of course they're good at code. Code is just the language. That's how I think of it. They're not necessarily bad at math because they're good at pattern recognition and like reproducing a pattern. But the problem is that it's not a strict mathematical framework, and so it becomes a little bit challenging to measure that and to keep it on the rails. Sequence models are actually very good with numbers. Like we use LSTMs, which are like language models. We use like XGBoost, like the tree-based models. Those actually do really well on language tasks. And actually, LMs don't do that poorly because they're a language model. And so if you're trying to do like a time series prediction, that's not that much different from a sentence. The interesting thing is, though, is that if, let's say you have a time series forecasting model already deployed and it's like really good at like forecasting inventory for some like restaurant or whatever it is, it's a mathematical problem. You've got a mathematical like tabular machine learning model already good at that. Ripping that out, replacing it with a language model, even though it might perform on par, you've just introduced a whole new infrastructure and a lot of different challenges. I did this. I took a time series data set and I tried to forecast it with LSTMs, XGBoost, and LLMs. And the LLMs did okay, but they did this weird thing. Instead of sometimes giving me a single number as the like weekly forecast, sometimes it would say 15 units, and it was a string, not a number. Now I've got like a processing problem with the output of that. So I wouldn't say they're bad at it, they're sequence models, but I think there's a lot of research that we should be doing there that could be really interesting, yeah.
How can they improve? Is it train them on, I don't know, math books?
I would. No, there's a paper on that. Yeah, I would dump a bunch of like mathematical papers into it and maybe even like a RAG system that's focused on that. That'd be my first step. Yeah. Yeah.
All right. Thanks, Claire.
Thanks, everyone.